And welcome back. So, our next presentation is going to be related to solar technologies. Specifically, our next presenter is from Morningstar, and Morningstar is the world's leading supplier of solar controllers for remote solar power systems. And they are going to speak about how they are using Zabbix to integrate it together with their data-enabled solar power product. Specifically, we are going to be talking about SNMP and MODBUS protocols for powerful and scalable system oversight and analysis of the obtained data. So renewable energy, very modern and interesting technology. And this presentation is going to be a proof of concept that, hey, you can use Zabbix even with, such type of hardware. So let's welcome Head of Product Management Team, Morningstar Inc. from USA, Brad Berwald. Welcome.
Hello, thanks for joining us today. My name is Brad Berwald. I'm the product manager at Morningstar Corporation, and today I'm going to be going over the integration between Morningstar solar charge controllers and the Zabbix remote network monitoring system. We've worked in partnership with Zabbix to provide integration for our products, including easy-to-use templates and pre-formatted data sets in order to speed your process of getting our products online so that you can monitor both your network data and solar power system data at remote sites. So today I'll be talking with you about the product overview and also a little bit about Morningstar as a company. So thanks for joining the Zabbix Online Summit 2020, and I'll go ahead and get started. First, a little bit about Morningstar. Morningstar is a leading supplier of charge controllers and inverters generally used in remote power systems. We'll be covering our solar applications, an overview of our product technology, some of the challenges faced in remotely monitoring off-grid solar sites, and lastly, an in-depth review of the Zabbix data solution for our products. So first, about the company. Morningstar is located in Newtown, Pennsylvania in the United States, and we are pleased to have sold over 4 million products deployed into the field since the company's inception in 1993. We currently work in over 100 countries and provide reliable remote power for mission-critical applications. Some of these areas include residential and rural electrification, commercial systems, industrial products, including telecommunications, oil and gas, and security applications, and also the mobile and marine application as well, which generally includes boats, RVs, and caravans. We'd like to think of ourselves as the charging experts because of our diverse product line and specific products designed for application needs, such as solar lighting or telecommunications. And we have one of the lowest hardware failure rates in the industry, which we're very proud to say. So some of our applications are reviewed here. Some others that I wanted to mention that are notable are the railroad industry, where remote signaling and track management is often remotely powered by solar applications because of its critical nature and the fact that there's not a readily available electric grid. Also traffic applications, early warning systems, signaling, messaging systems, traffic and speed monitoring equipment also can be easily powered for mobile deployment with a battery-based system. The oil and gas industry is a specific and notable market for Morningstar because oil field automation, measurement of the gas flow and pressure, as well as methane injection points that are used to keep the gas flowing and avoid well freeze-ups, all can be powered by solar power with a very modest amount of power for data monitoring. And since the pipelines traverse often very remote regions of countries, this is highly advantageous to get power where it's needed. In telecommunications, cellular base stations, backhaul links to provide the data for the sites, lay-in mobile radio applications, and satellite-based infrastructure all benefit from remote solar power. In these applications, the loads can be modest or they can be quite significant, and in that case can be used in parallel, where several of our controllers are combined together to charge a very large battery bank, often with a hybrid diesel genset in conjunction with other renewable energy sources to provide a hybrid power system. This increases reliability, provides diversity during inclement weather, and overall maintains the high integrity of the site link. In the cases of rural electrification, small amounts of DC power can be provided in remote locations of countries where there is still a developing region. There is no grid access, but there are, of course, great populace and needs for lighting and for cell phone charging for the population. We did a notable project specifically in Peru where nearly 1 million Peruvians were provided remote power access using 200,000 DC energy boxes. They provided basic 12-volt DC power, USB charging, and were distributed among the country in some of the most remote of locations. In addition to this, 3,000 integrated power systems for community centers were also provided. These were much larger in scale, provided AC power and 230-volt AC power, and also were used to provide more critical loads, including lighting, communication, and in some cases, health equipment. So we're very proud to have deployed probably what is one of the largest and most ambitious rural electrification projects in the history of the off-grid industry. And that was completed last year with our partner Tosi Green of Italy. And we're pleased to have completed that for the country of Peru. So a little bit about our products and technology. We have a diverse product set, anywhere from 50-watt power needs all the way up to products that handle 3.2 kilowatts. And we also provide a inverter system, both our SureSign and Morningstar Multi-Wave, which will be coming to market in the near future, to provide AC power and more robust high current charging capabilities from AC sources, such as the grid for backup or from generators. So together, all of these product lines make up a diverse set of products that really fulfill the variety of needs in a off-grid remote power system. Each of our products includes, in many cases, open communication protocols as well, and that will be the focus of our discussion today as we see how these open protocols can be used to provide remote management. So first, a little bit about what a charge controller actually does. It is designed to be situated between the PV modules and the battery. It monitors various system power and voltage readings, as well as temperatures, and is set to manage the batteries in order to provide long life, adequate charging, take the batteries through their various charging stages, and also manage the DC loads that are connected to the device and in which uptime is critical for. They can, of course, extend the battery life of the batteries significantly if they are set correctly and the right choice is made. And that depends a lot on the battery chemistry, the temperatures it will experience, and how it's to be used and how deeply it will be cycled or discharged each day to provide power to the system. We have products in both the PWM and MPPT line of charge controller topologies. In this case, here is an MPPT controller. And because it's the heart of the system, it actually is able to convert power, DC power, from the PV array to the proper battery voltage. So it has an integrated DC to DC converter. And it accomplishes the same methods of charge control for the battery, preventing overcharging and extending the life. In this case, it is also used with one of our inverter products in order to provide small AC loads, such as equipment that requires 120 or 230 volt power remotely in the field. So our product line, as I said, covers a variety of PWM charge controllers. These are pulse width modulation products, and they are a little more cost effective, a little bit simpler in nature, and provide direct charging from an equally sized nominal solar array. In the MPPT charge controller line, those that provide maximum power point tracking, the modules can be of a much wider range of voltages, much higher voltage, and will actually be monitored and tracked by the controller to provide the optimal operating point for the system. Our SunSaver and ProStar PPT line are used extensively in smaller systems under 1,000 watts, and our TriStar family is used for 3 kilowatts or greater, as well as being able to be paralleled. A notable product is our 600 volt controller, which allows the PV modules to be wired in series for a very high voltage input. And all the MPPT controllers will take the input voltage, they will convert it to the expected output to support 12, 24, or 48 volt battery systems. Our inverter line includes the SureSign and Multi-Wave inverter chargers. And then we also have a very extensive line of accessories that are used with each of these controllers. These generally provide protocol conversion, hardware interface adapters, and other items that can control relays to provide system control or actuate additional components in a remote off-grid system. The one we'll be talking about specifically today in more detail is the EMC1. This is Morningstar's Ethernet meter bus converter. It's a simple serial to Ethernet converter that also supports a real-time operating system and a variety of protocols so that our products can be connected to industry-specific applications using those standard protocols. And these would be MODBUS over IP or SNMP, and also can display a simple HTML web GUI to allow direct connection on a one-to-one basis with the product for simple status monitoring using any type of device, including mobile devices such as phones or tablets. So to talk a little bit in detail about our solutions for applications that we've partnered with in the case of Zabbix, we're going to be going over how systems can be scaled, remotely monitored in very large quantities, and can be managed in terms of being notified of remote alarms and activities and data logging. So one of the most common applications for service provider in remote locations. They need access points, they need point areas, and also, of course, to enable customer access in the field using Wi-Fi or LTE communications. So when these devices are deployed with solar, clearly they have to have their network equipment monitored, and which is pretty typical with the network management system, or NMS. And these network monitors can also now be enabled with the EMC and using SNMP and our partnership with Zabbix to make this far easier to integrate the power systems into that same monitoring system. So you have a single point of software, a single point of data collection, and both power and network bandwidth and status can be monitored at the same time. So what this monitoring can help achieve for us is the measurement of the true load consumption in the field. The radio's power levels will vary depending on the type, depending on the amount of usage, and of course, depending on the technology and frequencies used. So seeing what a load is actually drawing in the real world in the field throughout the day during peak and off-peak hours can be directly monitored in real time. Also, network outages, something we want to clearly minimize, and we want to ensure that the site is reliable and the network is on at all times to avoid customer dissatisfaction and frustration by the operating carrier. And the ability to monitor both power and network allows the root cause of network outages to be determined, whether it's a system configuration, bandwidth restrictions, or if it is in fact something that has caused difficulty with the power system itself, such as a depleted battery, insufficient solar, even electrical faults, or possibly tampering with the system can be detected. So ensuring power at the site also ensures that you have adequate PV to cycle the battery properly, so that when it is depleted of energy each day from powering the loads, that it is fully recharged the next day when PV power is available again. And this balance is difficult to manage because you have to always ensure power for the battery, protect the loads, but you may or may not have adequate sun each day. So a number of series of days of reserve power is often provided in the system to ensure that the site will remain up. So measurement of all of this data is clearly provided through the network monitoring software, sometimes in very high level of granularity. So you can see, hour by hour or even minute by minute, what is occurring in the system, depending on your monitoring and bandwidth needs. In peak time, you usually have more than adequate power, but off-grid systems may be system sized in order to handle a worst case scenario, which would be during the winter months or the off-peak months when you have less amount of sun hours and lower levels of solar insolation that can provide as much power as you expected during the summer. So during these worst case periods of the year, that's when monitoring can be really critical, because it's when you're most likely to experience an outage due to inadequate solar. So also, when you have long-term availability of data, you can look at month over month. You can compare season to season during similar power output periods of time, as well as look at trends and analyze the system's basically lifetime of operation. With a lot of lead acid batteries, a minimum of 5 years is generally acceptable. And with newer lithium technologies, we're seeing that extended to 10 or more years when adequately sized. So the batteries definitely can have a robust life as long as they are sized correctly and given adequate power. But monitoring the end stage of a battery, which most likely will occur at some time in the system, since many remote sites that are deployed for an extended period of time possibly can go through 1 or 2 battery replacement cycles, is really critical to understand. And knowing when you have a downward trend where power is declining over time, and the battery is beginning to show signs that its health is no longer adequate to support the system, can be detected with this long-term data analysis. So a typical system in this diagram shows one of our ProStar MPPT controllers connected to a solar array and a battery storage system. Loads can be typical among many of the applications I discussed earlier, and our EMC1 can be connected to the device in order to provide IP connectivity. And that generally is something that can be connected to a variety of services. In the above, you can see we use MODBUS protocol to connect to SCADA or other HMI data viewing solutions, which is common in automation and oil and gas. You can use simple HTTP or HTML web pages to get a simple look at a dashboard to understand what's going on in the system. And of course, when you implement SNMP, such as we have with the partnership with Zabbix, then SNMP can be used alongside the network monitoring software, and the Zabbix network monitoring software can be enabled to monitor the entire site with just one tool. And being cloud-based or server-based can have great applications for energy storage, data logging, notifications and alarms, and of course, a database, either native or external in the cloud, can be used to archive the large amounts of data that will be accumulated. We expect to see often in these sites, dozens are first piloted, and they can grow to hundreds or even thousands of deployed systems. So the software tool and the server must be one that's scalable so that it can grow in time and keep up with the needs of the data. So the benefits of using an IP-based solution, of course, is it's compatible with any network transport layer. And there's a variety of wireless applications in the field, including those from point-to-point, licensed, unlicensed, Wi-Fi, proprietary wireless protocols, cellular, and more recently, some notable gains in the satellite industry has provided lower latency and higher bandwidth. And with satellite, you can often reach almost any part of the world, which gives it great benefits for solar power applications. Also, another benefit of course, using SNMP is it's a very lightweight protocol. So when you are on a metered connection and it's wireless and data costs money, especially in these hard to reach locations, having low overhead UDP packets, minimal infrastructure for monitoring can make sure that you have minimal impact on the system itself in terms of overhead. So here's some examples of some dashboards with the Zabbix network monitoring software. You can see that native Morningstar SNMP support is provided by these tools. Again, we've worked to review the use cases, system needs for solar applications, as well as data sets, the MIB files already being imported, and device templates pre-configured for a variety of Morningstar product solutions that support the EMC1. These dedicated templates allow you to easily connect the hardware in an existing system and go about monitoring Morningstar's tools using your existing Zabbix implementation. Now, the performance visibility of the sites is available. You can either look at a very high level, seeing if there are any systems that have needs or are in a fault state, or you can dig into much greater detail by analyzing the time series data and allowing you to correlate that data with other aspects of the system to provide what is the root cause of the system and how that data is trending. Having at a glance dashboard management of the tool makes it extremely easy to scale to hundreds of sites, and with active notifications sent out by the Zabbix system, you can be told proactively when there is a pending issue at the site, hopefully before critical loads are dropped from the system. So if you can be notified, then using the bidirectional nature of some of the other protocols, system changes, corrections, extended runtimes, or even auxiliary charging systems such as generators can be activated to prevent an outage. So this kind of proactive monitoring really can only take place when you're working at scale using a tool such as Zabbix. So some differences a little bit here before I move on is that Morningstar provides some simple PC-based utilities that run on Windows software and can provide direct MODBUS capability for communication, very simple data logging on a very small number of devices. This is a functional utility we provide. It allows configuration files for the products to be uploaded and deployed to the controllers in the field, as well as basic troubleshooting. Morningstar's Live View is our built-in web dashboard that also runs on the EMC, and it allows a simple web page with everything displayed in HTML so that it can be viewed on any device regardless of operating system. But these two products are really meant for small scale systems, for troubleshooting and for site deployment and configuration. They're not really set to be scaled to work on systems that grow into the hundreds of operation. We can see that a cloud website and server, almost an unlimited number of devices can be connected depending on your computing resources and power. The protocols used can be either SNMP or MODBUS, both of these protocols being supported by Zabbix, which is beneficial for both telecom and industrial automation or smart city applications. This gives you the benefit of the real-time data display as well as the custom alerts and notifications that I discussed earlier. So you can set up custom logged intervals, downloading of extensive amounts of log data. Reports can be generated based on filtering that you provide, and of course, long-term historical data, which year by year becomes more critical to understanding the site's longevity. We've even seen in cloud-based systems where APIs are available and cloud-to-cloud integrations can be utilized that advanced data management, analysis, or intelligence can even be added onto existing servers by using additional third-party tools. So we find that it's really the only way to manage data of this scale and size. So in summary, that's an overview of Morningstar, our products, and the off-grid applications that we support. And we wanted to give an overview of the integration with the Zabbix monitoring system, which adds a great deal of value and capabilities to our products when used in the field. If additional access is provided via satellite or cellular, or in some cases fixed, wireless technologies, then the charge controllers can perform their duty of providing remote power for these systems, but easily integrating using the same protocols already being used to monitor these sites for a single pane of glass to monitor across the entire system deployment. So I hope this has been informative. Again, my name is Brad Berwald, head of the product management group at Morningstar, and we're pleased to participate in the Zabbix Summit this year. So thank you very much, and please reach out to either of the companies for more information on Zabbix's network monitoring tools, or to Morningstar for more information about our data-enabled remote power products. Thank you very much.
Hello, Brad. Welcome to the Q&A part. How are you feeling? You're at the tail end of the summit, and I think everyone's kind of waiting for the most kind of exciting end-of-line speeches, and we do have some exotic ones, yours included.
Great. Yeah, thanks very much for having me. I appreciate it. We're happy to be participating.
So a couple of questions for you. So your Morningstar templates, are they shared somewhere? Are they available for public? If not, do you plan on sharing them?
Yes, part of the partnership we're working out with Zabbix is to get all this integrated, and we're putting the finishing touches on how that will be available. And we would like to, make them both, easily downloadable as part of our SNMP support documentation, and also we can do some, cross-referring so that we can help our products get online, and hopefully you can definitely get them plugged into, major network monitoring access. So yeah, all that will be available probably within the next month.
Oh yeah, that's actually great to hear. In one of my previous Q&As, I talked with a representative of Softtechnica also regarding, making their templates available as maybe a standard part of the Zabbix package. So like I said, we're talking about exotic kind of solutions here, something that's really interesting, really niche, and it's great to hear that you guys are planning to making them publicly available for everyone to use. That's really valuable. Next up, as you maybe have heard, Zabbix, starting from 5.2, natively supports MODBUS and MQTT. Do you plan on using that? Maybe you're already using it in your environment.
Yes, MQTT is something that has come up quite a bit. Currently, our support now through our gateway product is for MODBUS and for SNMP. We're looking at future options to support other protocols, but generally within the solar industry, MODBUS has been a familiar protocol for a long time for automation and control. We also work a lot in the oil, gas, they would utilize that both for pulling of the data as well as real-time control, actually making configuration changes to the product. The SNMP is a more recent development, and that's to sort of get on the bandwagon with a lot of the telecommunications and IT related markets so that it's an easy transition using a protocol that they're already familiar with.
Thank you. Next up, so people were interested, how do you use report generation? How do you enable it? How do you implement it in Zabbix?
Let's see, in terms of within Zabbix, I couldn't comment on the way in which it's utilized right here. I'd have to refer to one of our product specialists. What I would generally say is that a lot of our customers are looking for trending data over a certain period of time. So they would set up regular intervals for the data to be collected and reported, because the long-term trending data, as I talked a little bit of my presentation, is about looking at the same site during different periods of time, or looking at the same site next to its peers to see how the power system may be varying. So regular report intervals that can be executed and then filtered based on certain conditions. There's really a few key parameters that someone can look at a solar site and understand at quick glance the health of the system. So they'd be focusing on the battery levels, the maximum power of the solar panel, and then just quick diagnostic check, is the controller showing any faults or alarms. And if they had that in a simple report at a regular interval, they can quickly be sure that hundreds of sites are in good shape. And then if one of them wasn't, they could drill down into more detail on just that specific site.
Yeah, thank you a lot, Brad. That'll be all from me, but feel free to stick with our chat and the Q&A section, because I think with an environment like yours, it must be of quite a lot of interest to our community and maybe some potential corporate partners or clients, because, yeah, like I said, we don't hear much from such exotic enterprises like yours, and it's really valuable to hear such a use case and how you do things. Thank you.
Yeah, great. Yeah, thank you very much. I appreciate being here.
We also appreciate you participating.